Today's lesson talks about the inverse and the contrapositive. These are statements. These statements can be made like the converse, which we learned about last class, all from a conditional statement. So let's consider the conditional statement below. If a hockey team gets a shutout, then they win the game. This statement is in the form P implies Q. Okay. If this happens, then this happens. Okay. Now, we're not going to talk right now about the converse because we talked about that yesterday. What I'm going to define for you, though, is what the inverse is. The inverse statement is P bar implies Q bar. Or this could also be read not P implies not Q. In other words, the opposite of P implies the opposite of Q. So let's take a look at the original conditional statement. The original conditional statement is if a hockey team gets a shutout. So P would be a hockey team gets a shutout. That's your P. And your Q would be then they win the game. Okay? So this is P and this is Q. So the inverse statement is P bar or not P implies not Q. So the opposite of a hockey team gets a shutout. Well, that would be if a hockey team doesn't get a shutout. Make sense? The opposite of getting a shutout would be not getting a shutout, right? Then they the opposite of Q. Q is then they win the game. The opposite of winning is losing. So then they lose the game. So from this conditional statement, we can create this inverse statement by negating P and Q. That's what it's called, negating. We are writing down the opposite of P and the opposite of Q. We're negating P and Q. That is called the inverse. So the contrapositive, which is another statement, is when not Q implies not P. So it's very similar to the inverse, except we switch the order around. So if not Q is they lose the game, then that's how we would start the contrapositive. If a hockey team loses a game, then we would put not P, and not P is a hockey team doesn't get a shutout or they don't get a shutout. So the contrapositive is if a hockey team loses a game, then they don't get a shutout. Okay? Make sense? If you want a cheat sheet or a quick summary, you can make a conditional statement out of anything. It doesn't have to be true, but you can make a conditional statement. And it's always in the form P implies Q. The converse, as we learned yesterday, will always be Q implies P. We just change the order of P and Q around. The inverse, P and Q stay in their respective positions, but now it's not P implies not Q. And the contrapositive is not Q implies not P. Okay? So we can make a conditional statement out of anything, or we can be given any kind of conditional statement. On the quiz, there was 2 conditional statements. And from that conditional statement, we can state the converse, inverse, or contrapositive of that conditional statement. Now, that doesn't mean that any of those statements are true. But if you're given a conditional statement, what we just wrote and read there is kind of like your cheat sheet of how to create the converse, the inverse, and the contrapositive. That would be a lovely thing to go on your unit end study sheet, as well as likely your final exam study sheet. Now, the question, it's not really an example, but the question asks us, which of the following statements above is true? So we've got 3 statements above, not 4, we've got 3. We got the conditional statement, we got the inverse and the contrapositive. What we're going to do now is assess whether each one of those statements is true. Now, I do apologize because sometimes when we have a question like this, it's going to require a previous knowledge. So, for example, in this question, you need some kind of previous knowledge of hockey. On the questions on the quiz, you needed a knowledge of multiples, and you also needed a knowledge of um, how your mark in a class is set up. Is there anybody in here that feels that they know very little about hockey? Okay, so let me just clear up some things, and maybe you already know this. A shutout is when you don't allow any goals. Okay? If your team doesn't allow a goal, you get a shutout. Okay? So, with that in mind, we can do this question. Now, when you do these questions for homework or you see questions on quizzes, there will be things that relate to things like this. And this previous knowledge may be needed to do some of these questions. If you come across something like this and you have very little knowledge of it, put that on your study sheet. Try to commit that to memory. I'm not going to be asking you a whole bunch of things about, like, it's not like you have to memorize the War of 1812 or anything to do any of this stuff, okay? But there are certain things that we fall back on. And yesterday when we talked about squares and rectangles and stuff, so there is some previous knowledge that's required, okay? All right. So, which of the following statements above is true? So we'll look at the conditional statement. If a hockey team gets a shutout, then they win the game. Is that true? Yes. Okay. If we define a shutout as at the end of the day, you haven't allowed one goal. Now, we should clarify a couple things here. It depends on how the rules are set up. If we're talking National Hockey League in 2004 introduced the shootout. And what that was designed to do was to make sure that at the end of the game, there's going to be a winner. When you leave the game, if you're at the game, there's a winner and there's a loser. So that being said, if we use the NHL rules as our guidelines, and this is an assumption, okay? This is an assumption. And when we're answering questions, it's not a bad idea to write our assumptions down. And that's a huge thing when you're answering applied math questions because they relate to the real world. So we are going to assume NHL rules, and I'm just gonna, sorry? It's a good question. Um, well, hmm, I guess the question I would have is a shutout, like let's say it goes to a shootout, nothing gets scored in regular time, nothing gets scored in overtime, and it goes to a shootout, and there's a winner. Um, is it still a shutout? And the answer is, Julie, I don't have any idea. So you know what? Let's do a little bit of research here and see if we can find out. Okay. Um, so I'll put NHL. Can you get a shutout and lose? When is it a shutout? 2009. Perfect. Alana, you won't be able to see this, but we will inform you of what we find here. Ah, here we go. Interestingly enough, let's just see if this is confirmed here. Okay. Yeah, apparently the answer is yes. So if we're going by the NHL rules, which are there, if a hockey team gets a shutout, then they win the game. Is that true or false? False, because what happens if you get a 0-0 tie that goes to a shootout? So that would be our counter example. So, so for the conditional statement, it's false, and the counter example would be a 0-0 tie after a shootout, rather, or after overtime. My apologies. Okay, so if you have a 0-0 tie after overtime, that counts as a shutout, but guess what? You can still lose the game. So, fair enough. All right, so the conditional statement is false. All right, now what we'll do is we'll assess the inverse and the contrapositive. So, the inverse is if a hockey team doesn't get a shutout, then they lose the game. Is that true? If they don't get a shutout, will they lose the game? No. You can win 7-6, right? You can allow 10 goals as long as you score one more than you allow, right? Or more than that. So the inverse statement is also false. And you can win a game 7-6. You can allow a whole lot of goals as long as your team scores one more than they allow. You're a winner, and you might not have even gotten a shutout. So the inverse statement is also false. Now let's look at the contrapositive. The contrapositive is if a hockey team loses a game, then they don't get a shutout. Well, what do you think about that one? Why? Right? And that's actually what our research proved, right? We researched it and said you don't necessarily win if you get a shutout. You can have 0-0 tie after overtime, and then it goes to a shootout. Evan Castell, will you please come to the school office? You have a visitor. And in the shootout, you can lose the game. Okay, if they lose the game, then they don't get a shutout. False, because you can have a shutout and lose. So, contrapositive statement is false because, again, you can lose 0-0 after OT if I don't want to say that. I want to say I want to be more clear. That's I don't know what that was, but that was a hot mess. You can have a shootout. I need to have this weekend come a lot sooner. You can have a shutout after OT, but lose in the shootout. Okay. So that is the contrapositive statement is false because you can get excuse me. You can get a shutout and still lose. All right? So we're going to do one more example. or even this wasn't even really an example, but we're going to do one more. We're going to do one example. So let's do it. If a number is a multiple of 6, then it's if a number is a multiple of 3, then it's a multiple of 6. Now, this is very similar to what you got in the quiz, except it was 2 and 4. Is the conditional statement true? If not, provide a counterexample. Be careful. What's that? Good catch. Yeah, if a number is a multiple of 3, then it's a multiple of 6. That's right. Good call. False. 9. Now what we're going to do is we're going to write out the inverse, assess its truth, and then we'll do the contrapositive and do the same thing. So the inverse statement would be, if a number is not a multiple of 3, then it's not a multiple of 6. So part B, inverse, if a number is not a multiple of 3, then it is not a multiple of 6. That is the inverse statement. Is that true? What's your counterexample? What's that? 9? Well, the thing is we need a number. Here, I'll tell you this. For this counterexample to work out, and bear with me because it is the end of the day, we have to pick a number that's not a multiple of 3, and for the statement to be false, then it would have to be a multiple of 6. Can you think of a number that's not a multiple of 3, but is a multiple of 6? No. No, because we want a number that's not a multiple of 3. 3 is a multiple of 3. What's that? No, it's a multiple of 3. I want a number that's not a multiple of 3, but is a multiple of 6. Is there such a number? No, there's no such number. Okay? This is a true statement. This is a true statement. If it's not a multiple of 3, then it's not going to be a multiple of 6. Okay? That's actually a true statement. The original statement was if a number is a multiple of 3, then it is a multiple of 6. Is false because, as Sky said, 9 is a multiple of 3, but it's not a multiple of 6. That was absolutely correct. But if a number is not a multiple of 3, then it can't be a multiple of 6. Okay? That's a true statement. True statement. Part D. So that was part B and part C, I guess, because the part C is the true. Part D, write the contrapositive. Write the contrapositive, and then we're going to assess whether or not that is true or false. And the contrapositive, we will take our inverse and basically just switch the front and back ends, and that will give us our contrapositive. So the contrapositive is, if a number is not a multiple of 6, then it's not a multiple of 3. If a number is not a multiple of 6, then it is not a multiple of 3. These statements aren't always the easiest to read because they've got nots in them, and you have to think of along those lines, and it's not always easy. But if we take a look at that, if a number is not a multiple of 6, then it is not a multiple of 3. Is that true or false? Give me a counterexample. You got her. 9 is not a multiple of 6, but it is a multiple of 3. So it's absolutely false. And the counterexample is 9, or any other multiple of 3 that's not a multiple of 6. Your practice questions that I'd like you to do are on pages 214 to 216 in your textbook, numbers 1 to 12. I'm thinking, because you have 3 days off, let's do a homework check. So at least part of your weekend could be spent doing your favorite subject.